Hey everyone, today we're going to be talking about prime factorizations. So before we start doing prime factorizations, we need a few definitions. The first thing we need to know is, what is the definition of a prime number? Well, a prime number is a number that has exactly two whole number factors, and those factors are going to be 1 and itself. So it's important that it says whole numbers, so you can't use any decimals here. And it has to be 1 and itself. So just so that we could have this in our notes, let's talk about the first 5 prime numbers. So the first one is the number 2. So when you're multiplying, the only way to get 2 is 1 times 2, and that's the only way. The next prime number is 3. For the same reason, the only way you can multiply and get 3 is 1 times 3. The next prime number is 5. So notice how I skipped 4. 4 is not prime because you can do 1 times 4, sure, but you could also do 2 times 2. So since there's more than one way to get 4, it's not prime. But 5 is. Then we have 7 and 11, and it keeps going forever, but those are the first 5. These are the ones that you're going to use the most often. Our second definition is, what is a prime factorization? So the prime factorization of a number is the list of prime numbers that will multiply to the original number. So in words, it's kind of weird, but once we do the examples, I promise you'll see what I mean. And the last definition is a factor tree. This is a diagram to determine the prime factors of a number. So I have 4 examples to do with you guys. Let's look at that first one. So it says, use a factor tree to find the prime factorization of each number below. So let's start with the first one. It's the number 48. So I'm just going to rewrite it right here. So factor tree means that we're going to be able to branch this out. So I always start with the first prime number. So starting with 2. 2 times what number would get me 48? So I know for some of us it's kind of easy to see, but for others you might need a calculator. Just do what is 48 divided by 2, and that would give you 24. So since 2 is prime, I'm going to go ahead and circle that 2. But 24 is not a prime number, so 24 I can split up even further. So again, it's an even number, so I know I can divide by 2, but 2 times what gives me 24? That'll be 2 times 12. 2 is a prime number, so I'm going to circle it, but that 12, I can still continue splitting it up. Because it's an even number, I know I can divide by 2, so it would be 2 times 6. 2 is prime. 6 is an even number, so I know I can divide by 2 yet again, so that would be 2 times 3. 2 is prime. Can I split up 3 any further? So in this case, no, 3 is also a prime number. Remember our list from up here? It's on my list. So you know you're done with your factor tree when you end up with 2 prime numbers. So all these numbers that you circled, that is what makes up the prime factorization. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Okay, now let's look at the next one. The next problem is the number 228. So we're going to do the exact same thing. We're going to break this down as much as we can, and it's easiest to always start with the number 2. Since this is an even number, I know this will work. So this would be 2 times 114. 2 is a prime number, so I'm going to go ahead and circle that. But 114 is even, so I know I can divide it by 2 again. And that would give me 2 times 57. 2 is prime. Can I break down 57 anymore? So I know 2 is not going to work anymore because this is an odd number, and it'll give me a decimal. And remember our definition said I needed whole numbers. So back to our list from above. Since I know that 2 is not going to work, let's go ahead and let's try 3. So 3 times what would give you 57? So you don't have to do this in your head. You can use a calculator, but it's actually going to be 3 times 19. 3 is a prime number, so I'm going to go ahead and circle it. But 19, can I separate it any further? So I actually wasn't sure, Remember that when you're home, you're allowed to use anything. So I actually Googled this, and I just typed in, is 19 a prime number? And it told me yes. So that means that 19, I cannot split it up anymore. 19 is a prime number. So all those circled numbers make up my prime factorization of 228, which would be 2 times 2 times 3 times 19. Okay, let's look at the next one. This time I have the number 300. So same as before. Let's split this up. So 300 is an even number. I know for sure I can divide by 2, and that would give me 150. 2 is prime, so I'm going to circle it. 150 is also even, so I know I can divide by 2, and that would give me 75. 2 is prime, so I'm circling it. 75 is not a prime number, but it's also not even, so 2 is not going to work here. So let's start with 3. And 3 does work. It would be 3 times 25. 3 is prime. But then let's continue breaking this down. 25 is not a prime number, so I know I can split it up. But 2 is not going to work because it's odd. But 3 also doesn't work when I type it into my calculator. So the next prime number on our list, if 2 and 3 both don't work, let's try 5. So if I divide by 5, that gives me 5. 5 times 5 gives me 25. And I know 5 is prime, so I'm going to go ahead and circle both of these. And since I ended with 2 prime numbers, I know I'm done. So the prime factorization of 300 would be 2 times 2 times 3 times 5 times 5. Okay, and our last example is 147. Okay, so all the other ones I started dividing by 2, but in this case it's not going to work because 147 is an odd number. So let's start trying with 3. So when I get 147 and I divide it by 3, I get 49. So 3 is prime. I'm going to go ahead and circle that. But 49 is not prime. I can split it up more. So here's the thing. It's not even, so 2 is not going to work. When I type it into the calculator, 3 also does not work. 5 is not going to work because 5 only works when the number ends with a 0 or a 5. So I'm going to go back to my list of prime numbers. 2, 3, and 5 don't work. So the next one I should try is 7. So when I divide 49 by 7, I get 7. 49 is a perfect square. So 7 is prime, so I'm going to go ahead and circle both of those 7s. And I'm finished now because I ended up with 2 prime numbers. So my prime factorization for 147 is 3 times 7 times 7. Okay, and this is how you find the prime factorization of any number.